Hello friends, myself Praveen Kajri. Welcome to the video classes. In this class, we will understand the meaning of prefix to the SI units. Right. So what is that? Prefix to SI units. So before understanding this prefix to the SI units, so we know the SI unit for length, right? So length is a physical property. For this we know the SI unit, that is nothing but meter, right? In smaller units we can express meter in terms of millimeter or micrometer, right? In bigger units we can express meter in terms of kilometer. So these are the different way of expressing the length. Either we can express it in terms of meter, or we can express it in terms of millimeter, micrometer, kilometer. So in millimeter, just observe this, we have milli in front of meter, right? Similarly micro in front of meter, right? Kilo in front of meter. Meter is a SI unit for length. But these milli, micro, kilo are known as, they are the prefix. Prefix means the anything which is written in front of, right? Anything which is written in front, that is known as prefix. So here meter, milli is written in front of meter, micro is written in front of meter, kilo is written in front of meter. Therefore these are nothing but prefixes which is written in front of SI units. Therefore they are known as the prefixes of SI units, right? So now from our high school science we know that 1 kilometer is equals to how much? It is equals to 1000 meter, right? So this can be written in the power of 10 as 10 raised to 3 meter. So that is 1 kilometer is nothing but 10 raised to 3 meter. So just observe these two. So here we can write 1 into, right? So that is nothing but 10 raised to 3 meter. So just observe these two. What we can see here is, in place of 1k, we have 1 into 10 raised to 3. Meter is the same on either side, right? So therefore here k, kilo, is nothing but 10 raised to 3, right? K is equals to what? 10 raised to 3. Kilo is nothing but 10 raised to 3, its value, right? So this is the value of k, that is the prefix. So that is multiplied to the SI unit meter, right? So therefore this is the multiple for this SI unit. So if you are using a k, kilo, as a prefix, the value for that is, the multiple for that k, kilo, is nothing but 10 raised to 3, that is equals to 1000. So like this we have millimeter, 1 millimeter, right? 1 millimeter. So this is equals to what? 1 into 10 raised to minus 3 meter. So therefore just observe, milli is equals to how much? 10 raised to minus 3. For the value of milli we have 10 raised to minus 3 multiple. That means milli means 10 raised to minus 3. Similarly we have micrometer, that is equals to 10 raised to minus 6 meter. Meter is same in either side of the equation. Therefore micro means how much? It is equals to 10 raised to minus 6, right? So kilo means 10 raised to 3, milli means 10 raised to minus 3, micro means 10 raised to minus 6, right? So these are the values for those prefixes. So what I am going to list here is, I am going to list the prefixes for the SI units that we come across during the study of science, right? And then their values, And what are the symbols? What are the symbols that are used to write these prefixes? So let us list that. So here in the first column I am going to write prefix. So next one is the multiples. So what is the value of that prefix? So then what is the symbol? Symbol for that. Symbol for that prefix. So let us start with a multiple 10 raised to minus 1. So this is known as deci. So what is that? Prefix for that is deci, 10 raised to minus 1. If the value is 10 raised to minus 1, then we have to use prefix deci. Right. So symbol for that is d, small d. Right. So now 10 raised to minus 2. 10 raised to minus 2. What is the prefix for this? So that is nothing but centi. Centi. So symbol for this is small c. That is small c. So 10 raised to minus 3. Then it is known as milli. Milli. The symbol for this is a small m. Right. So if its multiple is 10 raised to minus 6, then it is known as micro. Prefix is micro. For that multiple is 10 raised to minus 6. Symbol for this is mu. What is that? Mu. So if the multiple is 10 raised to minus 9, then the prefix what we have to use is nano. Symbol for that is small n. Right. If it is 10 raised to minus 12, then we have to use pico as a prefix. Symbol is small p. It is small p. So if the value is 10 raised to minus 15, 10 raised to minus 15, then we have to use prefix as femto. What is that? Femto. Symbol for that is small f. Alright. If the multiple is 10 raised to minus 18, 10 raised to minus 18, then we have to use atto. A-T-T-O. Atto. Symbol for that is small a. Right. So if the value is 10 raised to 21, minus 21, then we have to use Japto. Japto. Right. The symbol for that is small z. Small z. Right. If the multiple is 10 raised to minus 24, minus 24, then we have to use yocto. Y-O-C-T-O. Yocto. Symbol for that is small y. Right. So these are the prefixes for the SI unit. So first one is deci, 10 raised to minus 1. Small d is the symbol for that. So centi, 10 raised to minus 2. Small c is the symbol for that. Milli, 10 raised to minus 3. Small m. Micro, 10 raised to minus 6. Mu. So nano, 10 raised to minus 9. Small n. Pico, 10 raised to minus 12. Small p. Femto, 10 raised to minus 15. Small f. Atto, 10 raised to minus 18. A, small a. Japto, 10 raised to minus 21. Small z. Yocto, 10 raised to minus 24. Small y. These are the different prefixes. Now, if the value is 10 raised to plus 1, then what? That I am going to list here. So, prefix, multiple, and a symbol. Right. So if the value is 10 raised to 1, 10 raised to 1, that is 10, then we are using the prefix as deca. What is that? Deca. D-E-C-A. Deca. So the symbol for that is DA. dA, small d, small a. Right. If the value is 10 raised to plus 2, so 10 raised to 2, then what? So then it is known as hecto. Hecto. Symbol is small h. Right. If it is 10 raised to 10 raised to 3, then we have to use the prefix that is kilo. Letter symbol for that is small k. That should be small k. So if it is a 10 raised to 6, then we have to use the prefix as mega. Mega. Symbol for that is capital M. Right. If the multiple is 10 raised to 9, then we have to use giga. So multiple symbol for that is capital G. Right. If it is 10 raised to 12, then we have to use tera. Symbol for that is capital T. Right. 10 raised to 15, then we have to use peta. So capital P is the symbol for that. Right. If the multiple is 10 raised to 18, then we have to use exa as a prefix. So symbol for that is capital E. If the multiple is 10 raised to 21 plus 21, then we have to use zeta. So capital Z is the symbol for that. So if the multiple is 10 raised to 24, then we have to use Yoto. Symbol for that is capital Y. Right. So just observe these two columns. So here 10 raised to minus 1 deci, 10 raised to 1 is deca, 10 raised to 2 is hecto, 10 raised to minus 2 is centi, 10 raised to minus 3 is milli, 10 raised to 3 is kilo, 10 raised to minus 6 is micro, 10 raised to 6 is mega, 10 raised to minus 9 is nano, 10 raised to 9 is giga, 10 raised to 12 is tera, 10 raised to minus 12 is pico, 10 raised to 15 is femto, 10 raised to 15 is peta, 10 raised to 18 is exa, 10 raised to 18 minus 18 is atto, 10 raised to minus 21 is jepto, 10 raised to 21 plus 21 is zeta, 10 raised to minus 24 is yocto, 10 raised to 24 is yotto, and the respective symbols you have to remember. So what we have discussed here is these are all prefixes to the SI units. For example, centimeter. What do you mean by centimeter? Centimeter is nothing but 10 raised to minus 2 meter. Right. Let us understand this table by using some examples. So convert 100 centimeter in terms of meter. So this is the first example what we have to understand. So 100 centimeter, right, this is equals to, I want to convert this into meter, only meter. So I have to convert this centi in terms of meter. 100 as it is. So now centi, what is the value of centi? That is equals to 10 raised to minus 2 is the value of centi. So meter as it is. So what is this is equals to 100 10 raised to minus 2 means what? It is into 1 divided by 10 raised to 2 meter. So this is equals to what? 100 divided by 100 meter. So this is equals to 1 meter. So what is that? 100 centimeter is equals to what? That is equals to 1 meter. Right. So now let us take one more example. That is, convert 5 kilometer in terms of meters. 5 kilometer I have to convert it into meters. So 5 kilometer, right? Small k, small m. K is the prefix for the SI unit meter, right? This is equals to 5 as it is. Kilo means how much? That is equals to 10 raised to 3 meter, right? So this is equals to 5000 meter. So therefore 5 kilometer is equals to how much? 5000 meter. See, in a simple words, how to convert 1 kilometer in terms of meters? 1 as it is, kilo means 10 raised to 3 meter. So this is equals to 10 raised to 3 means 1000. 1000 into 1 is equals to 1000 meters. That is 1 kilometer is equals to how much? 1000 meters. Right. This is how we are going to use the prefixes for SI units and their conversions. How to convert this kilo in terms of a multiple, that is 10 raised to 3. So now let us understand in a reverse way how to convert 1 meter in terms of kilometers, right? So that I am going to write here. So convert 1 meter into kilometers. So first I have to write 1 meter, right? So if you want to convert into kilometer, that means I have to multiply this 1 with what? 10 raised to 3, that means kilo, right? Meter as it is. In order to cancel this 10 raised to 3, I have to multiply this with 10 raised to minus 3. That means this is equals to this value, right? So why I am multiplying with 10 raised to minus 3 and 10 raised to 3? Because I want to convert this unit in terms of kilometer. K means kilo. Its multiple value is, its value is 10 raised to 3. If you want to cancel 10 raised to 3, you have to multiply this with 10 raised to minus 3. So these two becomes equals to 10 raised to 0. Anything raised to 0 is equals to what? 1. 1 into 1, that is equals to 1 meter. Right. So this is equals to what? 1 into 10 raised to minus 3 as it is. 10 raised to 3 means what? K, kilo. So meter as it is. So that means 1 meter is equals to how much? 10 raised to minus 3 kilometer. This can also be written in a decimal form as 0.001 kilometer. 1 meter is equals to how much? 0.001 kilometer. 1 divided by 1000, that is equals to 0.001 kilometer. Right. So now let us take one more example. That is, convert 1 meter into centimeter. 1 meter in terms of centimeter. So again I have to write 1 meter as it is. So this is equals to 1 into 10 raised to, centi means what? 10 raised to minus 2. So I have to multiply this with 10 raised to 2 into 10 raised to minus 2 meter as it is. Whole thing remains equals to this value. So 1 meter is equals to how much? 1 into 10 raised to minus 2 plus 2 as it is into 10 raised to minus 2 means what? That is equals to centi. Meter as it is centimeter. So this value 10 raised to 2 is equals to what? 100 centimeter. So that is 1 meter is equals to how much? 100 centimeter. Similarly, 1 meter is equals to how much kilometer? 0.001 kilometer. You know how to convert that. So this is possible only if you know that list of prefixes for the SI units and the respective values. So you have to by heart or you have to remember that list in order to make these conversions. Hope it is clear now. Now we have to understand the meaning of mass and weight, right? Mass and weight. So generally we use these two terms interchangeably. That means whenever we are using the term mass, so we think that it is also weight. So it is not the case. So mass and the weight, the meaning of mass and weight is entirely different. They are not same. So then what is mass? So let me write the statement first. So mass is the amount of matter present in that substance. So this is what the mass is. What is mass actually? The mass means the amount of substance present in it. For example, let us take this chalk piece. What is the amount of substance present in this? So that may be 10 grams. Okay. So let us take 1 kg of apple. So what is the amount of matter present in that? That is equals to 1 kg. Right. So the amount of matter present in that substance is known as its mass. Right. So SI unit for the mass is nothing but what? That is equals to kilogram, kg. Right. So now let us take this chalk piece and let us check the mass of this substance on the earth surface, on the earth. So what is the amount of substance present in this? That is the same, that will be certain amount. So now I am going to take this to the moon. Right. There I am going to measure its mass, whether it is changing its mass or not. So it will not change its mass. What is the amount of substance present in this on the earth surface? That is equals to the same amount that is also present on the moon surface. So it will not change with the place. Right. So that means, so it is not depending on the place where you are measuring the amount of substance. The amount of substance is not going to change with the place. Right. So let us understand the meaning of weight now. So what is weight? Let me write the statement first. The gravitational force experienced by the matter is known as its weight. Right. The gravitational force experienced by that matter. If I take this chalk piece, if I leave this chalk piece from this height, what happens? It is going to fall to the earth surface. Right. So why it is going to fall? Because of the gravitational force. Gravitational force is acting on this chalk piece. Right. That force is pulling this matter towards itself. That means that gravitational force, that force is acting on this matter. Right. So that gravitational force, what is the quantity of gravitational force experienced by that matter? So that quantity of the gravitational force experienced by that matter is nothing but its weight. Right. So we know that from the second law of Newton's law of motion, right, force is equals to what? Mass into acceleration. Right. So force, this is nothing but the force, that is the force, gravitational force, the force experienced by the matter. If I hold this chalk piece here, it is experiencing certain force because of gravitation. What is that force? That is equals to how much? That is equals to mass of this substance. That mass is nothing but in terms of kg or grams, and acceleration due to gravity. This you know from your high school. Right. Acceleration due to gravity is always equals to 9.8 meter per second square. Right. So now I want to measure the weight of 1 kg of mass. So now you can understand the difference between mass and weight. So now what is that? I want to measure the mass of the weight of 1 kg of mass of a particular matter. So what is the mass of that matter? 1 kg. If I use 1 kg here, and what is the acceleration due to gravity? That is nothing but 9.8 meter per second square. This is equals to how much? That is equals to 9.8 kg meter per second square. So this kg meter per second square is also known as a Newton, 9.8 Newton. So what is the force experienced? What is the force experienced by that 1 kg of substance due to gravitational force? That is equals to 9.8 Newton. That is its weight. So that is the weight, right? So what is the weight of 1 kg of substance on the earth surface? That is equals to 9.8 newtons. So now same amount of 1 kg of substance I am going to take that 1 kg to the moon's surface. Their gravitational force is not similar to that of the gravitational force of earth. That must be smaller than that of the gravitational force of earth. Therefore the weight, this value is going to change. This value is less than the 9.8. That means the weight of that substance, 1 kg of substance, is going to decrease if you measure its weight in the moon's surface, because their gravitational force is less on that matter, right? So therefore this weight is dependent on what? Is dependent on it is dependent on gravitational force. Weight is dependent on what? Gravitational force. But mass is not dependent on gravitational force. That is, it is not dependent or independent of gravitational force. It is dependent on gravitational force, right? Because of the change in the gravitational force, its weight is going to change from place to place, right? So as it is not dependent on the gravitational force, the mass is same, or the mass is independent on the place where you are going to measure the mass, right? So the amount of substance is not changing with the change in the place of measurement, but the weight is dependent on the gravitational force. Therefore its weight is going to change its value if you change the place of measurement. For example, if you measure the weight of certain substance on the earth surface, its value is different. If you measure the same weight on the moon surface, its weight is different, but the amount of substance is not going to change. That means the mass remains the same. Then SI unit of this weight is equals to kg meter per second square, or it is also called Newton, or what is that? Newton. That is nothing but the unit for force, gravitational force, right? So this is what the difference between the mass and weight. So here let me sum up. Mass means what? The amount of matter present in that substance, that is known as mass, right? The SI unit is kg. Weight means what? The gravitational force experienced by that matter. The gravitational force experienced by that matter is known as its weight, right? So SI unit for weight is kg meter per second square or Newton. That is the unit for force. That is also the unit for weight, right? So the amount of substance is independent of the gravitational force, right? It is independent on the gravitational force. The amount of substance is not going to change with the change in gravitational force, but the weight is dependent on the gravitational force, right? Therefore the weight of a particular matter is changing with the change in the place of measurement, right? So these are the important differences between the mass and the weight. So you are not supposed to use these words interchangeably now onwards. So if you are telling the word mass, means it is the amount of substance, its SI unit is kg. if you are talking about weight, then it is the gravitational force experienced by that matter. So its SI unit is Newton, that is the unit of force. So in this class what we have discussed is, we have discussed the prefixes of SI units, right, how to interconvert the units, and then we have discussed about the difference between mass and weight, right. So in the next class we will discuss some more aspects of this chapter. Thanks for watching the video, and please share this video with the students in need. Thank you so much.